All right, thank you so much, everyone. So, good morning, good afternoon, and good evening. So, and then for the folks here in the US, thank you so much for getting up so early to listen into this section. So today I'll be doing the first presentation. My name is Jin Yuan. I'm an economist with the US International Trade Commission. So today my presentation topic is incorporating industry-specific wages and unemployment into the GTAP model framework. And then we are using this GTAP labor model to look at the US-EU trade liberalization scenario. This is joint work with my colleague, Catherine Antonio, and then also my supervisor, Dr. Rona Butcher. So first is a disclaimer that is the view expressed in these slides do not reflect the views of the U.S. International Trade Commission or any of its individual commissioners. So first, I'll talk about the outline of my today's presentation. First, I will discuss the motivation of the study, and then I will talk about the feature of the GTAP lab model, and then in particular, the simulation that we do. And then this is a comparison of the results between the standard GTAP model and the GTAP labor model. So the simulation is a full bilateral ad valorem equivalent tariff liberalization between the United States and the EU. And we aggregated this like standard GTAP database into 3 regions and 6 sectors, and then that's 2011 baseline. And then finally, we'll talk about the sensitivity analysis we did. That is, we tweaked the GTAP labor model a bit. We revised the substitution elasticity between the existing and the matched labor. And then I will talk about how it changes the simulation results. And in the end, I will also discuss the consistency of the labor module with the theoretical underpinnings of the GTAP model. So in terms of the motivation of the study, the standard GTAP model assumes full employment. So therefore, it has limited ability to account for the more realistic labor market features, such as the sector-specific wages and unemployment. So with that, we are trying to build a labor module into the GTAP model. And as the first step of the research, we applied this GTAP labor model developed by Evan Peterson in 2019 to an exercise of a tariff liberalization between the United States and the European Union. And then our ultimate goal is to build a CGE model with labor market features that is compatible with the modern labor economic series and have the country and sectoral level detail that would make it suitable for our agency's statutory work analysis. So as I said, this is still just work in progress, and then we welcome feedback from our audiences. And this like GTAP labor model, as I said, was developed by Evan Peterson back in 2019, and then the paper was published with the JGEA. It was a comparative static model with the frictional unemployment incorporated. So there were 4 different types of labor in this model. First is the existing labor, that is the employed workers who will carry on with their current positions and don't switch industries. And the existing labor is sector specific in the model. And then the matched labor are the new hires that are hired into each sector. And the recruiters are the ones who match those who are looking for a job with the job vacancies. And the unmatched labor is the labor pool that includes all the unemployed individuals who are on the job market, and the matched labor is drawn from this labor pool. So this GTAP labor model incorporates this matching function into the modeling framework. And the idea is that to hire new workers, firm must use labor, that is the recruiters, to match unemployed workers with the job vacancies. And then this matching function was incorporated into the GTAP model framework. So on the left-hand side, this MJ is the number of new workers that are matched into each sector in sector J. And then this 1 minus N is the unemployment rate. And then this RJ is the recruiting effort in sector J. And then RK are the recruiting efforts in all the other sectors except sector J. And then the mu J and the lambda J are the matching efficiency and the matching elasticity parameters. So this number of workers who got matched into sector J increases with the increase in unemployment and the sector's own recruiting effort. And this MJ, this number of workers get matched into sector J, decreases when the recruiting effort in other industries increase. And then this matching function has a constant returns to scale, and then it also has decreasing returns to this own recruiting, to this sector J's own recruiting effort, RJ. So with this matching function incorporated into the GTAP model, so that we have actually frictional unemployment in the model, the production structure in the GTAP model also changed. So as you can see here, that is in the upper level of the production structure, it is the same as the standard GTAP model. That is, the output is produced by using intermediate input plus the value added. But then in the GTAP lab model, we have an extra layer of production function that is for the unskilled labor and the skilled labor. They are both further divided down between the existing labor and the matched labor. And then the existing and the matched labor are considered to be imperfect substitutes. The economic rationale behind is that the matched labor is considered to be less experienced compared to the existing labor. And in the GTAP labor model, the standard version, the substitution elasticity between the existing and the matched labor are 2.5 for all 6 sectors, for both unskilled and skilled labor. And as I will talk about it later, we are changing this substitution elasticity also to see how it affects the result. And then in the GTAP labor model, this like Fisher labor's supply elasticity is set to 1 for both unskilled and skilled labor. And this is how the labor data in GTAP is modified in order to match the framework of the GTAP labor model. As you can see here, for both the unskilled and skilled labor, it is further divided down between existing and the matched labor. And then this is the US data. And then it was split using the labor turnover data from the Bureau of Labor Statistics, the BLS. And then also this like unemployment rate also is from the BLS, is used to calibrate the matching function. And then this unemployment rate by educational level is aggregated for the into the US unemployment rate for both unskilled and skilled labor. And then it was used to calibrate the matching function in the model. And then I've already talked about the feature of the GTAP labor model, and then I'll go to the simulation part. So here is the policy shocks that we are putting into the model, and then it is a full bilateral ABE liberalization between the United States and the European Union. And as you can see here, the EU ad valorem equivalent tariff on the US exports is bigger compared to the US ABE on the EU exports. And then the food and agricultural sector is having the biggest reduction in the ABEs, both from the US side and from the EU side. And then here is the simulation results for changes in the sectoral wages for unskilled labor for the US. And as you can see here, I'm comparing the results under the standard GTAP model versus the GTAP labor model. The standard GTAP model result is in the blue bar, and the GTAP labor model result is the orange bar. And then in the standard GTAP model, since labor is freely mobile across sectors, so when we are having a bilateral trade liberalization, there is an increase in the US wage rate of 0.34% for all the 6 sectors. But then, I mean, in the GTAP labor model, because we have frictional unemployment incorporated, and we have the searching and matching process incorporated in the model, so that's why the wage changes are different across different sectors. And then the biggest increase is in the food and agricultural sector. US sectoral wages in the food and agricultural sector for unskilled labor increased by 0.49%. And then you can see here the smallest increase is in the extraction industry, which is only 0.15%. And then the reason of the difference is because we are having the biggest tariff liberalization in the food and agricultural sector. And since there is labor mobility frictions, so that's why the wage increase is the highest in the food and agricultural sector. We actually have results for both unskilled and skilled labor, and I'm just giving you the result for the unskilled labor as an example. And then here I've actually done two scatter plots on the change in the relationship between the changing sectoral output and the changing sectoral wages for unskilled labor for the US. And then the orange line is the result in the standard GTAP model, and then the blue line is the result in the GTAP labor model. So as you can see here, there is a positive correlation between the change in sectoral output and the change in sectoral wages for the unskilled labor. And I want to make it clear that they are both endogenous variables, and then these are both simulation results, but I'm just giving you a correlation between the two. Here, the idea is that the bigger the increase in sectoral output, then, there is actually bigger demand for labor. So that is why the higher the increase in sectoral wages. As you can see here for the food and agricultural sector, the sectoral output increases by 0.17% and the sectoral wages increased by 0.49%. And then there is actually a slight decline in the sectoral output in the other manufacturing, metal, and extraction industry. And then that's because of the resource reallocation and also the US liberalization against EU exports. So, and then as you can see here, the bigger the decline in the sectoral output, then the smaller the increase in sectoral wages, and then the wage increase, the smallest sector is the extraction industry. And then this positive correlation is a pretty high R-square, it's like 0.97. Compared to the result in the GTAP labor model, in the standard GTAP model, we see a completely flat line. That is, the bilateral trade liberalization would result in the different increases in sectoral output because of the intensity of the tariff liberalization, but the increase in the sectoral wages is the same. It's 0.34, as I've just explained. And then here is the change in employment in each sector for the US, and that's for both the unskilled and skilled labor. And then the simulation results is giving us the percentage changes, but then we are doing a back of the envelope calculation that is using this percent change to time the US workers in 2011 in all these 6 sectors to give you this change in employment measured by the number of workers. As you can see here, employment increases in the food and agricultural sector by like 1,555 workers. And then that's because of the big EU tariff liberalization against US and food and agricultural exports. And then interestingly, we do see a big increase in the employment in the services sectors, trade and transportation and other services. And the services sector don't experience tariff changes at all. And then the reason is because of the resource reallocation, which results in a small increase in output in the trade and transportation and other services sector. So it's 0.02% for trade and transportation, and then 0.05% for the other services. That's the percentage changes. But since the services industry has is composing of the highest share in the US economy. So that's why a small output increase really translated into pretty big increases in the absolute value terms in terms of the increase in the number of workers working in those sectors. And the national unemployment rate in the US declined by 0.37% for unskilled labor and then 0.72% for skilled labor. And here is the change in welfare and household income for the United States. As you can see here, this bilateral tariff liberalization is resulting in an increase in household income and total utility and increasing welfare, both under the standard GTAP and the GTAP labor model. But increase is bigger in the GTAP lab model, and that's mainly due to the increase in factor prices, and then also the increase in the overall employment under the GTAP labor model, which is driving up the results on the macro level. So, and then I will be talking about the sensitivity analysis that the tweak we did to this model to see how results change. And then I've explained this like a substitution elasticity between the existing and the matched labor. So it is 2.5 for all the 6 sectors for both unskilled and skilled labor in the earlier version that I've talked about. And then, but we are just thinking that for this substitution elasticity between the existing and the matched labor, for certain sectors, that elasticity could be smaller because it is just more difficult for the matched labor to kind of substitute for the existing labor. And then these are still like arbitrary numbers that we are making it smaller for the food and agricultural sector and the extraction sector, and then also making it smaller for the metals and other manufacturing sector for unskilled labor, just to see how the results differ. And then, I mean, for these substitution elasticities, it would be best that we could get the result really from the empirical literature. We haven't found any, but if any of the audiences know any like relevant literature on this, then I mean, we'll greatly appreciate it. So when we make this change and then we run the same simulation, and then this is the result between the standard GTAP model and the GTAP labor model. And as you can see here, the result in the standard GTAP model, obviously it is the same. But then for the GTAP labor model, the effect on the labor market, that is, we are giving you an example of the effect on the US sectoral wages for unskilled labor, is not only changing magnitude, but also changing size. For instance, in the food and agricultural sector, now the increase in the US sectoral wages is 0.65%, and then compared to 0.49% in the previous version. And then for the extraction industry, we are now seeing actually a wage decline for US sectoral wages. And then it is minus 0.37% compared to 0.115% in like the previous version. So it seems that, I mean, this parameter is pretty important in terms of like the determining the labor market result. So we do think that like more empirical work on that would be helpful. And then, I mean, we are open to like discussion for that. And finally, I will talk about like the how this like incorporating the labor module into the GTAP framework would be compatible with the theoretical underpinnings of the GTAP model in particular and the CGE model in general. So what we found is that this matching function that is put into the GTAP labor model comes from the work of Huxley and Williams in 2018, which incorporates the matching function in the two-sector dynamic forward-looking general equilibrium model. And then Huxley and Williams built their model based on a matching model developed by Schimmer in 2010, which is also a forward-looking dynamic model to analyze frictional unemployment. And then, I mean, this framework actually also incorporates this reservation wage concept, that is the wage of the workers matched into the sector is actually determined by like a national bargaining process. So when putting this like matching function derived from a forward-looking dynamic framework into a comparative static model, whether there is theoretical consistency issue, that is whether putting it in would be compatible with the GTAP model fundamentals, is a question open for discussion. And then we do think that it is more like a general question here, that is, as I've explained, we are also in the process of building our in-house GTAP model with labor modules. And we are also thinking about the other options, for instance, incorporating a wage curve into the GTAP model framework. And I think my colleagues would also present like this work later in today's section. But then, I mean, we were also looking into this possibility, but we found that this wage curve was initially developed by Blanchflower and Oswald in 1995, which is empirically estimated using the historical wage and unemployment data. So when incorporating the wage curve into a CGE model, so is it the case that it is incorporating both the equilibrium and the disequilibrium, like the cyclical and structural unemployment? And then if so, kind of whether it would have like a possible theoretical consistency issue. So, and then this general question that I would like to open for audience for discussion is that we do have these like recent development in the modern labor economic series, but then, I mean, how to really incorporate these theories into the CGE model in a manner that would be consistent with the theoretical underpinning of the CGE model, and then how far we would be able to push for this effort. So I will stop here and then thank you, and I'm looking forward to the questions and feedback. So, thanks. Okay, I will exit the full screen here. And then any questions?
So yes. Looks like there is no question.
Yes, I have a question.
Okay, let me.
Or a comment.
Okay, let me, I will just try to. Okay. Yeah, I was actually trying to open this. Sorry, this is actually just the difficulty of using a platform that I am really not very familiar in operating. Yeah, so can maybe, okay, so I do see a hand up. So can anyone maybe just like read the question to me? Yeah. Yeah, hello, Israel first, and then maybe Sonita, yes.
Well, thank you, Jean. This is an excellent presentation. I really enjoy it, and this is very similar to the work that we are also doing. I have I mean, when I saw your graphs of different wages by sector, by type of worker, I think that's great progress, and this is something from the micro perspective, no? When we receive those changes from the CGE model, this is the kind of information that is actually relevant to assess what is happening to the distributional aspects. I was just thinking in your model, if you can elaborate a little bit on, I got the point of you have different elasticities of substitution between the matching workers and those that are, let's say, incumbent, no? But how is the movement across sectors working? Is it with the standard assumptions of GTAP, or how do you decide which workers move from one sector to another?
So basically, I think the idea here is that the movement of the workers is basically decided by this like matching framework. And then we also have descriptional unemployment incorporated in the model. So the idea is that, I mean, kind of just like this like number of workers get matched into like each sector is decided by like the recruiting effort, pretty much the labor market frictions basically kind of in each sector. But then, I mean, this substitution elasticity really kind of just like is looking at like how the matched workers is like substitutable for the existing workers. So in terms of like how easy these workers would be able to get matched or kind of flow into each sector. And then, I mean, it is currently like, well, in the, as I was indicating, it is like 2.5 for like all the sectors. And then for both unskilled and skilled labor. And then we were just trying to see when we are actually changing this like substitution elasticity for some sectors, how the result would differ. That is, we are actually making it more difficult for the workers to kind of just like move in and out for certain sectors. And then when we kind of just like when we actually make those changes, we realize that, I mean, the results do change a lot. Well, you still have this like positive relationship between the changing sectoral output and the changing sectoral wages, but then it's just this like kind of just like the line would be like steeper. That is pretty much now, I mean, for some industries like the extraction industry, we are seeing a decline in the sectoral wages here because, I mean, kind of just like for some sectors, we are just making it more difficult for the workers to mobilize. That's the idea. Thank you. And then I think it's Sonita.
Yes, thanks a lot, Jean, for a very, very interesting presentation. I have a question, first one in respect to your trade liberalization scenario, that you simulated, and then of course you used as a comparison for your research work. Did you cut simply tariffs between the EU and the US, or did you also cut non-tariff barriers? That was not very clear to me. What exactly, how did you design your shocks?
It's only tariffs, so we actually didn't really kind of just like liberalize like non-tariff measures, and it's only for the ag and the manufacturing sector, not the services, and that's just for illustrative purposes here. So.
Okay, so this is really to illustrate the dynamics and what happens in the two type of models. Thanks for that clarification. And that just picking up on something you just said now in reply to the other colleague. So basically, when you change the elasticity parameters, as you said, in the extraction sector, when you reduce the substitutability of labor, of unskilled labor, so basically you see a decline in the unskilled wages for those sectors, because these results, I don't think you showed us after you decreased, or you showed us, but in terms of wages or in terms of workers?
So that's actually is in terms of wages, basically.
Okay, so the wages decline, and you didn't show us the number of workers changes in this second experiment after you changed the elasticity parameters.
Yeah, so basically, in the interest of time, I was only showing like the
but do you remember? No, but do you remember if they also decline the number of workers in the extraction sector? That would have been my question.
Yeah, thank you. I actually need to go back to the result and double check. Yeah, right.
No worries. Thanks a lot. I will stop here.
Okay. Thank you so much. Yeah, that's a great question. I'll definitely.
Hi, Jin. Are you careful about the time that we also have 3 other presenters?
Yeah. So I do see here, and I do see that there were actually 2 extra questions. So kind of, I will actually defer to the chair. That is, in the interest of time, maybe kind of just like, should we bring this like discussion maybe out of the section, or I mean, I'm actually completely open here.
I think that's a clever idea. That can go into the chat, and then you can have private chats.
Okay. Thank you so much. Yeah, and I do also see a kind of comment like, sorry, that is also in the chat, and I'll definitely take notes of all those, and then I will follow up for sure.
All right, thanks for the presentation and also organizing the session.
Okay, thank you so much.
So I am Hom Pant. I'll just be looking after it. Is Rimi keeping the time?
Yes, I am.
All right, okay, please make sure that that you let us know about what's happening with the time. Yes. So can you please remove your slide, Jen?
Yeah, I'm actually, I've already stopped sharing, so.
All right, well, that's wonderful.
Okay.
So, so now we have the next speaker. Is Professor Maureen Rimmer. Is Maureen online?
Yes, I'm here. Do you want me to load my slides?
All right, wonderful. Okay, Maureen is a professor from Victoria University, Melbourne, here in Australia. And she will be presenting on creating USAGE-OCC. This is United States Applied General Equilibrium Model.
Yes,
with
if you like.
Occult technology.
Yes, okay. Am I free to load my slides or not yet?
Yeah, I think it is. It's up to you. It's over to you. And we'll learn a lot of this.
Okay. Thanks very much, Hom.
So you'll have 20 minutes for presentation and 10 minutes for discussion.
Okay.
So that discussion time can be reduced to 7 minutes to cover up the time lost in the beginning.
All right. Okay.
All right.
So what we're doing here is creating USAGE-OCC, a CGE model of the United States with a disaggregated occupational dimension. Okay, so it's the slide that, hang on, I'm just going to get this out of the way of the slides. Don't know how to. Okay, never mind. So the usage model of the US economy has 392 industries and is built around a benchmark input-output table for 2012. We have updated by simulation that model to 2019. We created usage-OCC model by adding usage detailed occupation by industry matrices for 2019 that identify numbers of jobs and wage bills. The occupation data we used is part of the BLS Occupational Employment Project, EP, and the data identifies 789 occupations in about 300 industries. So what a wonderful resource. So it looks easy, doesn't it? But it was far from easy, because in the paper that goes with these slides, we describe in detail how we resolve major incompatibilities between the BEA and the BLS industry classifications, and how we recovered missing jobs from the BLS 6-digit occupational data. The paper also describes how we reduced the occupational dimension from 789 occupations to a more manageable 233. But we did it in a way that minimised the loss of skill, experience and education detail. That is, we tried to aggregate like occupations. But I won't go into that anymore now, but I can answer questions about that if anyone's interested. What I want to talk about now is the labour market module we have built for USAGE-OCC. There's a diagram at the top that goes some way to explaining it, but the words, I'll get onto the words. The labour market module has 5 key ingredients. The first one is the division of the workforce into categories at the start of the year T, reflecting workforce activities in the year T-1. So you can see the categories there on the left-hand side of the screen, categories in year T. They are formed at the start of the year and they're based on activities in year T-1. The category you present in for the next year depends on what you were doing last year. For example, if you're an economist employed in year T-1, then you would present at the start of year T as economist employed. If you're a cook, unemployed, short-run unemployed in T-1, then you would present at the start of year T in the category cook, short-run unemployed. But it's not only the activities in T-1 that go into the categories, because we have new entrants into the labour market. They weren't in the labour force the previous year. So apart from the new entrants, you inherit the characteristics of your category from what you did last year. So that's the first part of our labour market module, the categories. Then the second part is to determine the labour supply from each category to each activity. So you see the arrow going from category T down to activities in year T. That is, people in the categories supply their labour to different sorts of activities in year T. And this is done via a category-specific optimisation problem that we solve, which figures out which activities people in a category wish to perform in year T. These category-specific occupation optimisation problems capture the following principles. Firstly, people in long-run unemployment become discouraged. This is a discouraged worker effect, and they offer less effectively to employment activities than do employment and short-run unemployed people. Another characteristic of our optimisation is that people in Occupation O offer strongly to continue in Occupation O. So if I'm an economist employed, I want to go on and be an economist employed next year. That's my strong offer. And if I'm a butcher, I want to go on being a butcher. Thirdly, people in Occupation O cannot make effective labour supply to an Occupation M if the qualifications for M are incompatible with those of O. For example, a chef cannot easily or effectively offer to be a surgeon. So that when we've got through those two first bits, A and B, we have now set up the supply from categories to activities. Demand, on the demand side, the demand is the usual CGE demand. Demand for labour in each occupation is specified for each industry via cost minimising problems and then aggregated across industries. So that's the usual. We get the demand side from the rest of the model. The supply side comes from this labour market module. Having got so far, the next thing is specification of a wage adjustment processes reflecting demand and supply. We adopt sticky wage adjustment equations. These equations recognise that when a shock affects either demand or supply of workers in occupation O, it takes some time to adjust, for the wages to adjust to their market clearing level. So, usually 4 or 5 years. The final thing we need to cover in our labour market module is the determination of everyone's activities. Who gets the jobs and what happens to those who don't get jobs? Now, the important thing about who gets the jobs is you need vacancies to get jobs. You can't change occupation. You can't go from occupation O to occupation M if there's no vacancies. So first of all, we think about vacancies and we work those out by taking demand for workers in a particular occupation and subtracting the desire from the incumbents to continue in that occupation. They're the vacancies. The model then describes competition to fill vacancies in occupation O between new entrants, unemployed workers and workers in other occupations. So there's competition to fill the available vacancies. Employed workers who make an unsuccessful offer to change an occupation, they fall back to their original occupation. It's held open for them. If short-run unemployed workers make an unsuccessful offer, they are now facing their second year in unemployment, so they fall into long-term unemployment. If long-term unemployed workers fail to make a successful offer, they stay in long-term unemployment, and unsuccessful new entrants go into short-run unemployment. So that's how the labour market generally works. Now we get to the messy bits of it. How do we specify occupation mobility? Jean had a lot to say about occupational mobility, and so do we. The ability to offer to occupations is important in the category-specific optimisation problems that generate supply to each occupation. In specifying occupational mobility, we took account of 3 factors. We took account of wage differentials between occupations. We took account of the physical requirements of occupations. And we took account of education, training and experience requirements and progression possibilities from one occupation to the other. In specifying the occupational mobility, we used an occupation to occupation mobility factor, MF, calculated as follows. There's an MF formula for the mobility that would allow you to go from O to M. So, all right, so you can see there's 3 factors in the bottom line of that mobility factor. One has to do with wage differences, and the bigger the wage difference, the higher the value of the term in the bottom line, X alpha wage diff. So if you, and the second term is a physical requirements factor, and it tells you about offering from where it's, like what kind of restrictions there are in occupying from one type of physical requirement to another. Normally, if you're in the non-physical occupation, we give, and you want to move to a physical occupation, we give you the number 2, which is, and if you're in any other situation, we give you the number 1. So that means what we're trying to get there is the bigger you make the bottom line, so the bigger you make of this physical requirement factor, the harder it is for you to change occupations, move from O to M. So if say O was a non-physical occupation, like clerical assistant, you get it, and then the clerical assistant was thinking of moving to occupation M, which is builders labourers. You'd get a 2 because that's a hard transition to do. It's hard to move from non-physical work into physical work. The third term is a compatibility in education, training, experience, and progression. Ideally, if the occupation M is a lot like occupation O, you get the number 1. If it's if you need the same sort of experience, education, and training, or they are close to each other in industry progressions, occupational progressions, then you get the value 1. For all other occupations M, you get the number 2. So if M is very close to O, the mobility factor will come out close to 1, and if M is not close to O, it will come out much less than 1, and you'll not be allowed to offer effectively to those occupations. So you offer effectively to occupations that are close to you in wage small wage differences, close to you in physical attributes, and have the same sort of education, training, experience, and in the same professional loop. Okay, so that's it. That's the end of the setup of the model. We made this detailed occupation industry model for a client, and we conducted an illustrative application before we passed it over to the client to make sure that the model was working the way we wanted it to work. We simulated the effects of a mandated 10% increase in real wage rates for low wage occupations. This is a bit like the programs that President Biden is introducing at the moment. There are 14 occupations in the BLS data that had a median wage rate of less than 29,500. They are mainly in food service, personal care and household services industries, and they account for 20% of the jobs, but only 9% of the wage bill. So we introduced a real wage increase for these workers in 2021 as a sustained 10% deviation from the baseline over a 4-year simulation period. We won't be able to go into the detailed occupation results, but we'll give some summary results. This first one is we looked at real GDP factor inputs and the average real wage of this experiment. You can see the top 2 lines are average wage rates in job weights and average real wages in wage bill weights. You see that the average real wage this is for the economy as a whole, went up in job weights relative to wage bill weights. Why is that? It's because the wage we put up with a 10% increase in wages with the low wage workers, and they are a larger share of the jobs than they are of the wage bill. They are a 20% share of the jobs. So that 10% wage increase puts up the average wage in jobs weights higher than the average real wage in wage bill weights, because the low wage workers are only 9% in wage bill weights. Now, putting up the wages like this is bad for employment. You see aggregate employment falling strongly, and as aggregate employment falls, the rates of return fall, and as a consequence for that, and down goes investment, and within a lag, you can see capital is edging down. That's the green line, capital input. Real GDP is somewhere in between them. So as you can see, this is not good for GDP, this experiment. What about the low wage occupations themselves? Here we show the labour supply and employment for the low wage occupations and the average real wage in jobs weights. See, the green line is the average real wage. It goes up 10%. If you put up, that was the experiment. You can see that there's first of all, the thing to notice is, of course, the employment falls. You've made these workers more expensive, employment goes down, but you're putting up the wage makes offers into this sort of employment by suppliers attractive. So they're attracted by the higher wage and the supply goes up. So there's a big gap opens up between the wage, the labour supply and employment. And the sticky wage adjustment mechanism isn't working for these low wage occupations. We turned it off because the experiment is to maintain that average real wage up at the 10% higher. So for these workers, and only for these workers, we've turned off the wage adjustment mechanism. And so the gap remains between labour supply and employment. But what about the supply and employment and average real wages of the other occupations? Well, we have an occupation substitution elasticity that's very low. So when you put up the wage of the low wage workers and drive down the employment in each industry of low wage workers, the high wage workers go down as well at the same time because of the low substitution elasticity. You can't substitute easily from one to the other. So the employment of the other occupations falls sharply in this sim. That's the blue line. The supply to the higher wage occupations, the red line, it's in the first year, 2021, you see it falls, but nowhere near by as much as the employment, the labour supply. The labour supply falls nowhere near as much as the employment in those occupations. So there is some leakage of these high wage workers to attracted by the higher wage in the low wage occupations, but that leakage is very low. As we saw before, we are not. There's a big wage differential. It's very hard for you to offer from out of. If there's a big wage differential, you can't offer from an occupation to the one for which there's a big difference. So the labour supply is not going to fall as much as the labour supply in the first instance, and so the real wages start falling, and they'll fall until the labour supply, the gap between the labour supply and the employment disappears. We did a slight overshoot on the labour supply, but the average wages are starting to increase a bit, and that will disappear shortly outside the simulation period. So what are the takeaways from the experiment? Well, the deviation in the baseline in the aggregate employment from the baseline in the aggregate employment in the fourth year is for aggregate employment is -1, a bit over -1%. Employment in all occupations
Hi,
is
Maureen, we have 2 minutes to go.
Okay, thank you. Employment in all occupations is adversely affected. For low-wage occupations, the average wage fell by over 2%, and for other occupations, slightly less than 1%. Employment in the low-wage occupation is damaged relative to employment in other occupations, mainly through the damage to the industries in which low-wage occupations are concentrated. Those industries are like things like household services industry. Nearly all the workers in that industry are low wage workers. So there's no high wage workers in that industry to be damaged, and the wages and the employment falls quite strongly in that industry. And then the other big takeaway message, I suppose, is that rectifying inequality, wage inequitable wage disparities without adverse employment effects requires policies such as negative tax rates that raise incomes for low-wage workers without increasing the cost to employers. The trouble with this experiment is we did increase the cost to employers. So, concluding remarks, USAGE-OCC could be used to create baseline projections of employment by occupation and training requirements. This could complement those by the BLS. But generating such projections from USAGE-OCC would also allow testing of the effects of occupational employment on occupational employment of different scenarios for demographics, technology, and trade variables. Another thing USAGE-OCC could be used to do is to analyse the effects on employment by occupations of policies in trade areas, environment, public finance, etc. Generating results at a detailed occupation level would be a major step towards working out the income distribution implications of policies. finally, I'd just like to say we're on the verge of having a regional version of this model, but it requires further work on the data and solution algorithms, and it's not yet ready to go into the operational stage. Thank you.
Thank you, Professor Rimmer, and this is a fantastic presentation. I hope this will come out as another green, black, blue, and this will be a red book. Contains everything.
A multicolour rainbow book.
All right, okay. So now it's time for us to have some discussion.
Yeah.
If there are any questions from the audience, please raise your hand. And so Maureen can see you. And
Maria, I can see Maria. Hi, Maria.
Yeah.
Hello, Maureen. Thank you so much for this very interesting work. I think we are all worried about inequality, and really digging into how to model that properly is very important. And thank you very much for the explanation. I was just wondering whether, maybe I missed it, but whether you can explain a bit in more detail, how would you model? You have a lot of information on occupations, and then if I understood correctly, you model they can either remain unemployed in the long or short run. Did you use past trends, or how do you model that? I was wondering how workers can move into different status and.
Well, okay, so the workers at the start of any year, they get themselves in the category, and then they're going to offer to employment. The offer to employment in the coming year. What they do is we have to look at where are suitable places for them to offer. Now, most people, we allow them to offer to the same occupation they're doing this year. So overwhelmingly, people, incumbents are incumbents. They like to stay working in their own occupation. But there are natural progressions in the data, like you could be a junior professor and go to a senior professor, or the really high thing in a university is to go to an administrator. There's natural progressions, or go to the dean of the department, vice chancellor. There's natural progression. So we allow people to supply their labour strongly to those as well, but mainly to their own occupation. And then we look at all the other occupations. You have a look. We've got 233 of them. Which ones are really inappropriate? We don't say no to anything, but we want to build up a picture of where you're most likely to offer to. And we build that in with that mobility factor. We build in a mobility factor that looks at looks at your occupation and what are the potential places you could go to if you didn't want to stay on in employment in your own occupation. And so people offer to those, but there's a lot more people offer than there are vacancies, and you've got to have a way of rationing them. And the effectiveness of your offers depends how strongly you can offer to the different occupations. Now, if you go into short-run unemployment from employment, your skills start to atrophy a bit, and you lose a bit of confidence, and it's harder to offer into employment when you're unemployed, from an unemployed position. And further, if you still, after a year's trying, you can't get a job, you're still in unemployment, then you're going to fall into long-run unemployment. And people in long-run unemployment only offer half as effectively. The level of their offers is not as great as employed people or short-run unemployed people. So this is a kind of picture we build up. We have demanders demanding it, but there's a lot of churning. The US market's a good market. There's a lot of churning, so it's not a disaster to fall into short-run unemployment because people are leaving jobs and getting sacked. There's vacancies. You can get a job if there's vacancies, and that's the way it goes. Like in France, it's not so easy. It's a big problem to lose your job in France because there's very few vacancies. But the US labour market's pretty good that way. I think that's the way it goes.
So in the interest of time, can I thank Professor Rimmer here? And if there are any questions, Israel, do you want to ask some question?
Yes, I have just a question. Thank you. This was very good presentation. I would like to ask about gender. I didn't see it in your mobility function. Is it considered, or is it not part of the data that you have?
No, it was not. It was not part of the EP data that we had. The gender, we didn't have that at all. But we are doing another project in Europe where we are doing the gender, and we have done gender in the past. But yeah, yes. So basically, that wasn't part of the package of data we received. Obviously, we could work on that at a future date, but no, it's not there at the moment. But you see, we're like the matching stuff that Jean was talking about. It'd be interesting to see how that worked on a model as disaggregated as the one we've got, because there they only had skilled, unskilled. We've got like chef, store stacking, stacking the groceries. We've got detailed occupations, and I think that matching is less of a problem, because if you're demanding a chef and you're supplying a chef, you know what you're getting. And so it'd be interesting to see how the matching idea went with a detail. It'd be a nice test to check it out.
All right, thank you very much. I think there are no other questions, and we don't have time for that too. Thank you very much for this interesting presentation.
Thank you.
And it's going to be an encyclopedia for us.
Thank you.
And our next speaker is Dr. Israel Osorio Rodarte from International Development, the World Bank. And he will be presenting on the topic, the distributional impacts of trade, the World Bank CGE-GIDD model used in applied trade policy simulations for Rwanda. And this appears to be a very interesting exercise. And the floor is to you, Rodarte. Please go ahead. Israel.
Yes, hello, thank you. I'm trying to put my screen to work. I need to restart the Zoom. Can I go back?
Can I swap with the other presenter so you can?
Yeah, that would be great. That would be great if the.
All right. So can I call upon the next presenter, Assistant Professor María Latorre from Universidad Complutense de Madrid, Spain. We'll be presenting on the EU-Mercosur agreement, an in-depth analysis of CO2 emissions and the labor market results. Well, the floor is to you.
Thank you. Thank you very much. Let me share the slides. Can you see it?
Yes, that's fantastic.
Okay. So good morning, good afternoon, good night, whatever applies. Thank you very much to Jean for organizing this session. Let me put my clock on. I have 20 minutes, right? And so this is joint work with Hidemiti Jonathawa and Sojana Letseyuk. I would also like to acknowledge the contributions of Gabriela Ortiz on previous work, not this paper, but has done a great job, and also the excellent research assistance of David Suarez Cuestia and Carlos Javier González Cabrera. Okay, so without any further ado, let me show you the, well, let me see whether I can pass the slide first. Just a second. A bit of problem here. Okay, something is going on here.
Yes.
There you go. Okay, so let me show you the plan for the presentation. I will offer an updated view of the agreement. I'll briefly explain the model, the simulations, the results I'll focus more on the result sensitivity to the wage curve assumptions, and I'll offer some conclusions. So the agreement. Well, after Russia's invasion of Ukraine, the recovery from COVID is in danger, and import dependencies have been put on the table. There is a new vision of allies and partners in the world. The production of food, fertilizers, and energy is problematic. And therefore, the perception about the ratification of this agreement, I believe, is changing. This is a deep trade agreement. It includes provisions for safeguarding the environment and labor standards. It offers protection against imitation of 357 geographical indications of the EU traditional products. It's the largest ever in an European agreement. It covers public procurement, digital trade, trading services, foreign direct investment, and many other important and new things. And compared to the most recent trade agreements of the EU, if you see the comparison of population, the second column is of world population in percentage, you see this is the largest ever for the EU, Mercosur, 9.2% of world population. In terms of GDPs between Japan and Canada, between those agreements, in terms of trade is slightly lower than the rest, but what is important from these agreements is the savings in tariffs, which is also, it's much larger than those previous agreements. Much larger population covered. It's true that they have a smaller GDP per capita than the two other countries, similar in trade, but much larger tariff savings. Now there is around 850,000 jobs in the EU related to exports to Brazil alone. Mercosur alone is about 2.2% of EU's trade goods and services, and that's similar to the agreement of Japan and Canada. But as I said, it really implies a much larger reduction in savings and therefore costs. And so to give you an idea, this could be like 4 billion in tariffs savings, discounting the UK, of course. Okay, so just to give you an idea, if you look at the red diamonds in this figure, you see that for most of the sectors, those red diamonds are the tariffs in Mercosur countries. And this is manufacturers. And you see that they are, for most of the sectors considered here, much higher than the world average, which is the horizontal orange lines that you see in the figure. So that's why we're saying it implies very big savings. Now, regarding the model, I'll be presenting the CGE results, but we've looked at many other aspects, like we've conducted some gravity models on the agreement and the product space. In reality, in this paper, we are extending previous work focusing on the impact on Spain that we conducted for the Spanish government. But here we present the results for the EU. And compared to previous paper, we cover many different aspects of this agreement. So trade in both goods and services, which cannot be taken for granted because, for example, many new quantitative trade models focus on goods alone. We cover the impact of multinationals and also public procurement. And importantly, we use the texts that are available for the agreement. We look at the annexes that are available. So that implies we have introduced in this model the negotiated tariffs and quotas, the opening of services, of FDI, and of public procurement based on those texts of the agreement. And regarding our CGE approach, we include imperfect competition using a MELITS approach in 9 manufacturing sectors. Then we include the operations of multinationals in 7 services sectors. The model has 41 sectors, by the way. So this is in line with our previous paper from the latest years. And we include unemployment, which is very much the focus here, using an unemployment wage curve a la Blanchauer and Oswald. Regarding MELITS, we use the approach of Palistretti, who is one of the ones that have included MELITS in a CGE framework. We use his Pareto distribution parameters. And therefore, we model MELITs in several manufacturing sectors, which sometimes can be problematic, but in 9 manufacturing sectors. And we also include important features of the original MELITs model, which has firm entry and exit, which is not always the case when MELITs is modeled in a CGE framework. And regarding the FDI story, we have services sectors that have 3 types of products. The ones provided by domestic firms producing locally, the ones produced by multinational firms producing locally but coming from different countries, and also the imported varieties of services coming from different countries. And importantly, we model a different cost structure for the domestic firms and the multinational firms. They differ in the use of intermediates and the labor and capital that they use. And the lowering of the barriers to FDI implies lowering costs for multinationals, and that affects their entry and profitability. Importantly, we also include an imperfect competition framework a la Krugman 1980 in the American Economic Review. And what do we model? I think we are also original in how we model the agreement. We look at the impact. This is not a dynamic model, I should say that, but we model a cumulative impact of the subsequent develop how the agreement unfolds, so to put it, right? So we have different results for year 1 after the agreement, year 5, year 11, and year 16. And what do we shock? Well, importantly, as I said, we look at shocks that try to resemble the negotiated texts, and we look at tariffs that in reality, we call them tariffs in the simulations, but cover quotas and tariffs, which has implied a huge effort in translating both tariffs and quotas negotiated at the HS8 or HS6 level into GTAP sectors. And then we include the reductions in the non-tariff barriers in trade in goods and services. We have been careful also about how we do this. We assume that it's easier or at least less difficult to lower the tariffs, the non-tariff measures related to non-technical measures such as automatic licenses, and a lot of difficulties to reach the Mercosur countries that are exporters from Europe face. And we feel there is less scope in the reduction for barriers related to SPS and TBTs, NTMs. We also find there is more scope for liberalization in Mercosur than in the EU. For the World Bank, we use, well, I think they are pretty famous, these non-tariff measures estimations from the World Bank. And for services, we use the OECD estimations. And again, very hard work in converting CPS sectors into GTAP and all those conversions across different versions of the CPC and so on. And then we also model reductions in the barriers to FDI in services sectors, and also public procurement, which in reality allows us to do 2 things. First, in principle, public procurement would be open at the central government agencies level. So we simulate an initial reduction in the barriers, NTM's barriers, looking at how they have been negotiated in public procurement. And then for the latest 2 years that we model here, we consider the possibility that it could be extended to regional agencies, also opening public procurement. And we also think this simulation is a way of capturing that after time, agreements take time to develop, and more conservative NTM simulations, we believe we've been conservative in those reductions in the barriers, could be deepened in the future. So let me show you basically what we get. I'll focus on the results for year 16, and then I'll expand to cover the impact of the different assumptions for the wage curve also for that year. So basically, we find that all signatories gain. For Europe, for example, I believe this is sort of the strongest positive impact that we've seen in the literature, precisely because we include many components of the agreement that have not always been considered. And then we derive a very positive impact also for Argentina, Brazil, Paraguay, and Uruguay. And of course, we get there is an increase in employment after these big expansions in the economy. And importantly, let me go to the next slide. We find that because there is more activity, higher GDP than before, we get an increase in the CO2 emissions, but importantly, the increase is of a smaller scale than the increase in the GDP. So this is telling us that we are really transitioning to cleaner sectors with this agreement. And also importantly, because all what related to what we hear in the press and to the concern related to the Amazon and so on, we find that the contributions of agriculture to the CO2 emissions is very small. So the story is more related to services contributions and to private consumption contribution to those CO2 emissions. This could be extended to consider greenhouse gases, which we have not done so far. But regarding the CO2 emissions, this is what we find. Now let's go to the wage curve. So basically, we model this negative relationship, a quite simple relationship to model the labor market, which tells us that the lower the unemployment, the higher the wages tend to be, and the reverse, right? So the more unemployment you have, in general, you need to increase wages less to hire more people intuitively. This could be an explanation of this relationship, which has been backed by several empirical studies. So in numbers, what we put in the model is that the local real wages responds to the changes in unemployment. So we have the initial unemployment, what would be the level of unemployment after the impact of the agreement, and it responds with an elasticity, which is negative, and usually in the literature, it is given a value of minus 0.1, which is what we use for our central estimations. This implies that a 100% rise in unemployment causes, it's a negative elasticity, causes a 10% fall in the level of wages and vice versa. We also assume, of course, we have to give a number to this initial level of unemployment. So we take that from forecast because we have updated 2014 GTAP data to 2022. And then we have also that labor, 50% of the labor in each sector is sector specific and cannot move to other sectors. So only 50% of the share of labor in each sector can move in this model. That's our central estimations. And what I'll be presenting now and looking at more carefully is, let's change the value of that elasticity, how wages respond to unemployment. Let's change the level or the value for the initial level of unemployment. Let's make unemployment exogenous so that there is no, you cannot create new jobs, and also run this exogenous unemployment with and without the 50% specific labor across sectors. So let's begin with the So let me show you here at the top of the table, you see our central estimation. I'm looking here to keep things manageable at the impact for the EU-27. And we find this 0.13 GDP increase in our central scenario. And then we have two values that are smaller. So one is half of our central estimation, and that the other one is quite extreme, 100 times lower. And then we look at greater values for that elasticity, 50% larger or 100 times larger, to keep it very extreme. So what we get is that with a smaller elasticity, the wage responds less to the changes in unemployment. In our case, the larger activity will lower the unemployment rate. So wages will go up, and that is what we find. They move in a negative way, but here in this part of smaller values, the wages are less sensitive. So that makes it possible to increase the number of jobs or the number of people hired with a lower increase in the wages, and that allows firms to increase more the number of job created because it is less costly. In line with the previous presentation, wages are a cost for firms, and then if that cost responds less to the unemployment, the wage increase is smaller, then they will increase more the number of workers, and that results in a higher volume of trade and in a higher volume of GDP. And the contrary applies to the case in which that elasticity is more responsive and has a larger value. So this is basically the idea of the elasticity of unemployment. Then if we go to the initial values, for example, for Europe, we have assumed that the EU initial level of unemployment or unemployment rate would be 9.18%. What happens if we have gotten a wrong forecast because it's a future forecast, so you get that wrong. So fortunately, we increase that level of unemployment. Well, here first is we reduce it. It is 20% smaller, 50% smaller, and we later increase by 20% and 50%. So fortunately, if you have a look at this, you look at the GDP, it's not very sensitive to this assumption. And the same applies to employment and wages. So fortunately, if we get that forecast for the future level of unemployment that we put in our initial benchmark, is not that serious. Of course, the idea is once more, if unemployment is larger, then the wage increases will be smaller. You have a higher pool of workers from which you can hire. And then the wage increases are not that big because you have a lot of workers to choose from or to employ in your firm, and that makes it cheaper to employ them, and then that expands GDP a bit more than what we find in our central scenario. And now let's look at the case of new unemployment, or better said, we assume that the initial data in our model have an unemployment exogenous that is behind that labor of worker, that amount of workers and labor that is behind our initial data. But the model would not be able to change that because unemployment is exogenous. So in this case, of course, the level of employment cannot change after our simulation. So most of the adjustment goes through wages. So what happens is that wages react more, and that is bad for employment, and but which he cannot move, but for firms in a way, and this makes the impact for GDP, which is here, and also for trade, a bit smaller than in the case in which you have unemployment. And this is very common in the literature.
Maria, we have 2 minutes to go.
Thank you very much. When you introduce unemployment, then you usually get larger shocks. Very quickly, just to say something about the CO2, we have modeled, as I said earlier, the basic idea is this agreement is not about agriculture, it's not about services. So if you look at the total imports coming from Mercosur countries to the entire EU, you would be maybe surprised to find that only 15% of those imports are agriculture. So to conclude, we find that all signatories countries gain in this agreement. It favors specialization in cleaner sectors because we find that GDP increases are larger than CO2 emissions increases after the agreement. This goes beyond agriculture. Of course, I haven't talked much about it, but it's of a strategic nature. And now that we see this conflict can be even more important, it is a source of growth and employment, helping to fight inequality and poverty. And regarding the wage curve, in line with the literature, so we obtain results that are in line with the literature. Results are not very sensitive with respect to the initial level of unemployment assumed. They are more sensitive to the elasticity of wages with respect to unemployment, but that usually works in a way in which the lower the elasticity, the higher the impact of the agreement, and the lower the increase in wages. And then assuming exogenous unemployment implies that the results are somewhat less intense. You get more positive impacts if you introduce unemployment. And that's all for the moment. Thank you very much for your attention.
Thank you, Maria. It was a very interesting presentation. It's very thorough work. Can I just ask the first question? Why do you need to use a gravity model?
No, maybe that was confusing. We did that for a broader report. So we looked at very different aspects of Mercosur, but today I was only using the CGE model. So not for today's presentations.
So the CGE model itself distributes or determines the direction of trade.
Yeah.
All right. Okay, that's understandable. Now on the wage curve, the function that you are using is the wage rate is a function of unemployment rate.
Correct.
With a given elasticity. Can you invert that function and say that unemployment rate is a function of the wage rate? Because the wage rate is determined by the model in equilibrium. And because of that, you can determine the level of unemployment. So the question is that function invertible? That you can write on both sides. So instead of minus 0.1, can that be written as 10?
Yeah, I see your point. I think both things are moving in our adjustment in the model. So it's hard to say what is moving first. So both are interacting. So I guess it goes in both directions. Basically, what we introduce is this idea of the literature is that if you have higher unemployment initially, and for example, that was clear in our results because wages do not have an initial level in the model because of the numerator and so on, it's 1, right? So we take the idea that an initial level of unemployment helps to increase wages more or less after the simulation. I think that's the way to think of this adjustment because initially wages
so we have percentage change. We have percentages coming, whatever the form your model is. But given the base unemployment rate, whatever it is, you can calibrate and make some adjustments on that. But if the function is invertible, then you have got endogenously determined unemployment rate because of the wage curve.
And I think that happens to, oh, sorry, maybe I interrupted you.
Yes, sure, I finished.
No, I think that happens through the adjustment, that they really are both interacting, but maybe what is clear, at least to me, is that at the beginning you have an initial pool of workers. If that is larger, because unemployment is higher, unfortunately, but if that is higher, that makes it easier for firms to hire more people at a lower wage. And I think that's what happens at the initial equilibrium. I'm sure that later there is the elasticity, makes the response higher or lower and so on. But I think what you have at the initial benchmark equilibrium is more or less worker from which you can hire.
All right. So if there are any questions, please come forward.
So I raise my hand, so I assume I can ask a question.
Right.
Okay, perfect. Thanks a lot, Maria. I mean, I can see how much work has really gone into this simulation and into assessing the EU-Mercosur agreement. Many thanks for that. I have only one comment, and it's really linked to this wage curve you have implemented to simulate labor market effects. I mean, in a way, as it is now, a rise in unemployment doesn't cause cost to the model. I mean, if you think about it in the real economy, if the unemployment rate would double, I mean, obviously, this would be linked to extreme pressure on the fiscal system, social security, taxes, unemployment benefits, which is really in the EU in the magnitude, in an extreme magnitude. I mean, in your model, it's not accounted for that. And that also explains the results, because you can double unemployment rate. Of course, wages now could be even lower. Actually, there is a positive impact in the model as it is now. And of course, that explains the results you obtained. But if you would factor in a doubling, the cost linked to doubling of unemployment rate, of course, results would be completely different. That is just a comment to make. Thanks.
Yeah, I think that's a very good point, Tornitsa. So thank you for raising it. As you say, the public sector is fixed, its operations, but I think that's a nice feature in a way. I see it may have this drawback you have pointed out, but we say, that trade agreements won't be a problem for sovereignty of the governments. They will still put money where they want. So we won't want to change the reaction of the public sector in a way. Maybe it could be doable to look at what you're saying, but we do have that GDP, if you have lower unemployment, is a problem. So that would, if unemployment is larger, in this case, it's the opposite. Okay, let's put it this way. You lower unemployment because of the agreement, right? But then you have more people consuming. So you have many other knock-on effects in the economy, not going through the public sector. I agree with your point. That's totally true. But you have many other reactions in the economy that could be bad. In this case, it's good because you are employing more people. You have a larger compensation of employees in general, even if it's not proportional to the increase in employment. And then you have other knock-on effects going through the economy. So, for example, you would increase the amount of tax revenues because there is more activity in the economy. So maybe you would be able to cover, I don't know.
I didn't mean the impact of the agreement. Of course, you simulate a cut in trade costs, you have an increase in GDP and lower of employment. I was really only referring to your sensitivity scenario where you just double unemployment and GDP doesn't decline. You see what I mean? Of course, I don't refer to your assessment of the Mercosur agreement. That's very clear. As you say, you have a lot of secondary effects and that is reflected by the CGE framework. I'm really talking only about the sensitivity, or whatever you call this sensitivity analysis, doubling unemployment rate and then these results. But by doubling unemployment rate, obviously you cannot keep everything else fixed. You see what I mean? I didn't refer to the impact of the agreement. That's clear.
No, that's a good point. It's one should be careful about saying we double unemployment. It's something serious. Exactly. Yeah, absolutely. Exactly. No, I fully buy the point.
All right. So thank you very much, Maria. It's a wonderful presentation.
Thank you.
And so can I ask our friend Israel, are you ready?
Yes, I'm ready. Thank you. Everybody can see my screen now, right?
All right, that's great.
Yeah. Okay. Thank you. And thank you for Maria for jumping in. This is the problem of having a new computer at home. But no, I would like to just close this session with my presentation. We call it the distributional impacts of trade. And what I'm going to do is present some of the work that we have done in the past, the approach that we use to analyze the distributional impacts of trade. And I'm going to talk about what are the new projects that we are starting in the World Bank, to serve better our clients in what they want is to know what are not only, I think, the distributional impacts of trade policies, but also the creation of jobs. That's the main reason. That's what they want to hear. How many jobs is this trade agreement going to bring to my country and where are they located? So for this reason, I'm going to start with the introduction, but I organized this presentation in 3 parts. I'm going to just briefly explain how we build this model. And we have 3 main components. One is what we call the gender disaggregated labor database. The second is our CGE model, which is the envisaged model that was developed by Dominique van der Mensbrugge. We have also the micro simulation part, which is the global income distribution dynamics model. I'm going to explain briefly these 3 parts and how they are interrelated. And I'm going to show you later one application that we are working on for the case of Rwanda. So as I mentioned, we are going to discuss these three parts, the envisage and the GIDD model, and I'm going to focus on what is needed specifically if you want to replicate this type of analysis in a given country. So the first part, I have this thing, okay, is about what we call the gender disaggregated labor database. We built a global database that wanted to, we use this to disaggregate the labor accounts in the GTAP database so we can have gender and skill level for the 65 categories of the GTAP database, and that has a global coverage. This was a very ambitious project, so we rely on a lot of household surveys that we have at the World Bank. We discovered that we have very good data in terms of household budget service, but our coverage of labor force service is not that great, and it's not part of the specialization that we have in the bank. So we are finding all these issues. We are now working with the ILO. We are working now with the jobs team at the World Bank to bring more of these household surveys to create both the wage build and the volume of labor and wages in a global consistent database that can be used for doing CG model. And we disaggregated this by skill level and by gender. There is a strong process in doing that. As you know, the data that comes from the household service or micro data is not compatible with what we look in the macro data. No? So, and also the household service usually don't have the level of detail or the level of observations to basically construct aggregates that can be scale up to the macro level at the 65-digit level. No? So when Maureen was talking about the very detailed input-output table that she has with 300 sectors, I mean, that's the Rolls Royce of data. No? What we have to do is operate in a more data scarce environment. So sometimes we have to get the household survey data. They are not meant used to measure necessarily labor outcomes. So we try to complement that with labor force service or try to get the better data for a big sample of countries. Then we harmonize the national classification systems for industry and occupation into the international systems. We built initial estimates, and then we cross-compare with other estimates from our own sources, from the ILO, from the GTAP value added of labor, and then we create a database that is probably not perfect, but that allows us to basically disaggregate the GTAP-10 database into 4 categories of workers. So we have male, female, and skill and non-skill based on education. And I'm going to follow up on that, why we use education, which has also its problems. So that's what we have done in terms of construction of data. We use that data to send it to our NPSH model. And as you know, the most important aspect of this model in terms of labor is that it's a dynamic model. And we have changed an important assumption in the dynamics of labor growth. So we are not following the standard assumption that skilled and unskilled labor grow at the same rate as the working age population. We take the information that we have from household surveys, and based on that, we use what we call a pipeline effect, which is the constant enrollment ratios scenario to basically send from micro to macro the change in the volume of labor that we will have in the in each one of the subsequent years. And this is very important because for us, in the case of developing countries, especially for the cases of Africa, just because of the size of the growing population and because of the existing number of people that is educated, we see that Africa contributes contributes by a majority of the new skilled labor that is joining the global labor force. So in a global model, this is very important. As more jobs more skilled jobs are being created in Africa, that changes the comparative advantage of the African countries vis-a-vis other countries in the world. So for us, that is very important. We construct this, again, we take a collection of household surveys, observe what are the initial shares of employment. We project that using the household surveys. And then those new volumes of labor by skill are sent into the macro model, which is a recursive dynamic CG model. So just to close the connection, we have down a micro simulation framework that is called the income distribution dynamics model. And just to close these ideas in this dynamic macro and micro data, as I mentioned, data does not always coincide, And I will say that the biggest effort in all this simulation exercise is trying to reconciliate what the macro and micro data are telling us. In this general framework, what I received from the macro are changes, and this is the GIDD methodological framework. What I receive are changes in labor volumes, in wages, in the equivalent variation of income, and the level of prices. And I receive that for each one of the years and for each one of the countries in our simulation. I pass that from macro to micro, and then this reconciliation is what is actually difficult to do. So the main issue is that we cannot pass changes in the level of wages because wages and labor typically are coming from a different base. So what we pass are changes in the level of employment and also changes in relative wages or changes in wage premium. By using this information that we send from micro to macro, using the gender disaggregated labor database and the population projections, what we are trying to do is to minimize the inconsistencies between macro and micro data. And still, in our macro-micro connection, in our model, what we try to do is instead of passing changes in levels, we pass changes in relative volumes and relative wages. And basically, this is how we can trace any changes that happen in the macro into the micro side. In terms of, I just put this slide just to show you that the constant enrollment rates, that is the long-term assumption on education, is more, it brings more education rather than the standard CGE assumption. So the standard CGE assumption is between the different levels of the global population projections that is done by IASA. But basically the constant enrollment rate is a pessimistic scenario. The enrollment rates are frozen, but in the long run, it implies a stagnation of skilled labor, but it still is higher than the typical assumption of the CGE models. So what we have done is we have a big project in the case of the Africa Continental FTA. This was a report that we did in 2020. We are doing a follow-up report for that will be released later during this year. And in the case of the Africa Continental FTA, we did several simulations. One is the tariff liberalization that comes with the agreement, and that liberalization started already in 2020. when all the countries sign the agreement. Then we have reduction in non-tariff barriers. This is, again, very standard of what other CG modelers are doing. We incorporate non-tariff measures into the database. Then implementation of trade facilitation measures. We basically show the iceberg trade cost parameters. And in the new report that is coming, we are talking about changes in FDI and deeper integration beyond trade, or beyond the tariff, non-tariff, and implementation of trade facilitation. This is basically the result that I would like to show you very quickly. For the cases of Rwanda, Rwanda has gains that are important, but they are not comparable to the gains that comes as an overall for the whole African region. And what we see is because Rwanda is already very liberalized with respect to the rest of Africa. So for that reason, the gains are smaller. And what we see in Africa and in the case of Rwanda is that most of the gains come from the non-tariff measures, which are the orange size of the bar, and also from trade facilitation measures. So the reduction of tariffs, since tariffs are already very small, doesn't bring a lot of gains, not to Rwanda, not to the rest of the continent. But the big gains that we see are coming from the reduction in non-tariff measures and the implementation of trade facilitation. Now, we also account for what is going to happen with deeper integration in the after, if we have a shallow or a deeper agreement, and that has also important consequences. Now, the thing that we were able to do by combining the gender disaggregated labor database, the micro simulation, and the envisage model is that it allows us to have some estimates for what's happening to wages and what's happening to poverty. And we can also have a household survey with a new vector that allows us to draw maps and say effects at the regional level. So for the case of Rwanda, it can lift up to 300,000 people out of poverty by 2035 in the cases of the deeper after integration. The SAM in Rwanda is driving the results, and most of the gain will come from the agricultural sector. Now we can say that the average Rwanda wages will increase in 5.4% with respect to baseline by 2035, and dramatically, it increases the rate of unskilled female wages, which are growing at 8.9%. And those comes from the CGE model. One of the things that is important to do this type of work when we are doing this at the national level is that the baseline is very important for the measurement of poverty. So usually what we took is the growth rate from the SSPs. And then when we project poverty, we tend to work also with poverty economists, and they will tell us, your model, your baseline is actually going very high, and you are projecting a big decrease in poverty by the year 2035. And this happens recently. So for example, the SSPs were developed in the year 2012 or 10, no? And they are very optimistic. Probably the SSP2 is very optimistic at this stage. So when we use that to project our baseline, the level of poverty reduction in the baseline for Africa is already very, very high of what it's expected. No? So we needed to adjust these growth rates, and that obviously that affect the changes in each one of the simulations. There are many things that we can cover in terms of the integration that we do for for this macro micro simulation when we work at specific countries. Usually we have this workhorse model that we apply at the global level. And when we are doing country-specific simulations, either the government or the country economists say, you know, my country behaves in a different way. No? So we start to calibrate some of the parameters and we start to do some micro simulation specific results, no? that can help us to tailor-make these models for the clients. So we have a workhorse model, we apply it at the global level, and then we interact more with clients when we want to do country-specific simulations. One of the things that is very important for us is to try to assess what are the distributional consequences in terms of the geographic areas. No, we have the luxury of working with household surveys, so in that sense we have gender, the number of children, no, the location, access to roads, the infrastructure of the household, and that is very rich in terms of doing a micro simulation when we are doing tailor-made simulations. Nevertheless, when we see the impact in the region, one of the main effects of what is going to be the impact on a specific region is related to government investment. No? So when they open up a new trade agreement,
Osorio, we have 2 minutes to go.
Yeah. So when they open up a new trade agreement, usually it comes with investment to certain regions and certain areas. No? And that investment doesn't exist. No? So when I have the household survey, and I say I have 10 regions, the simulation models will tell me is in these big metropolitan areas where most of the economic activity is concentrated. I will need to bring external information on new investments, on new plans or no cities that are going to receive certain flows of money and infrastructure so that I can actually model that those workers are going to move into those new emerging areas, especially in developing countries, and that's where the economic gains might pop up. Otherwise, my model tells me that it's going to be the same cities, no, or the same places where the economic activity is located now. So with that, just let me close the presentation and let's open the floor for questions.
Thank you, Israel, for this fantastic presentation, and it's a very, very thorough examination of what happens to Rwanda and broader African economy under various trade agreements. Now we have got some time for question and answer, if there are any questions. So anyone would like to raise hand? Oh.
Yeah, so has.
Okay, yeah.
I think you're on mute.
All right, can you unmute
yes,
yourself?
yes,
Good.
I
Okay.
was muted. Thanks a lot for telling me this. Thanks a lot, Israel. A very interesting presentation. I think this combination of micro and micro and macro dynamic simulation is really something. I have a couple of questions. The first one is, I see that the gender effects are very large. Do you, and of course now we didn't have time to go into the reason for that. What would be your explanation for this? I mean, it's really large gender effect. How would you explain what is driving those effects? On one hand, in the model, in this gender disaggregated data you have, and how the model is accounting for that. And also like in reality, right? I mean, is it micro enterprises that suddenly, you know, to resume new activity? What would be the driver behind that? Then another question on your last slide, you didn't, maybe I missed it. What is on the y-axis? It's not it's not mentioned, it's not titled. If you can just repeat, because I also tried to find your presentation, but I couldn't. So if you could send to us your presentation, that would be also much appreciated, as it is very, very interesting. And I'll stop here. Thanks.
No, thank you. The gender effect is mainly driven by the number of women working in the sectors that are growing. And particularly for the case of Rwanda, the agricultural sector employs a larger number of female, no? In that sector, the sector is growing very fast, and the relative wages for women in that sector are lower. So when they want to bring more employment, so they start to bring more women. And obviously you have a parameter of substitution between male and female, which is something that we calibrated and tested and that. But I will say that is the main driver is the volume of women that are working. And I will say that instead of the elasticity is the sum, no? And the GTAP sum is for Rwanda is very strong on the agricultural sector. Now, I am a little bit worried because Rwanda is a country that has been growing very fast during the last 8 to 10 years. No? So the sum that was estimated and that we have in GTAP probably doesn't reflect the structure that we have now. No? So in these countries, that is the main driver. We did an exercise for Vietnam some years ago. And as you know, Vietnam changes very rapidly. So with the incorporation of the CPTPP, the CGE model tells us that Vietnam was going to keep exporting textiles. But by the time that we did the exercise, Vietnam already jumped into electronics. No? So by not having an actual sum that tells us that, that changes the conclusions of the results. So in this case, is being driven by the amount of women that is employed in agriculture, the relative wages, but mostly by the social accounting matrix that doesn't capture other activities that are already present in Rwanda. So we are working with authorities. Now, what we have seen is that a lot of developing countries are eager to use CGE models right now, no? Because of many things that are happening in the world, and more sums are being collected and updated. So we are working closely with the GTAP Center. So as we receive more sums, we can send it to Angel, and they can process it faster, and so they can make faster updates into the database. And in terms of the graph, it was thousands of people. And I wanted to show really what is happening. So the poverty rate in Rwanda is going down. But if you account for the poverty rate going down plus the growing of the population, actually the number of people are going up. No? But when I put those numbers in poverty, I see a big decline. No? And that's what I meant, that when we just use the growth projections of macro projections, we are overly optimistic. So it's very optimistic, our baseline. Yes, probably the difference with respect to baseline are gonna give me that there is a decline in poverty, but our baseline tend to be very optimistic. No? And this is something also that you cannot see until you have the poverty numbers. No? Usually the macro accounts hide that dimension.
Thanks, and please feel free to send us the presentation. Yeah, thanks.
Any more questions?
Yeah, I've just got a comment, Hom, if that's okay.
Sure.
It's really great to see someone struggling so hard with the data and not letting imperfect data stop you. Well done, really well done.
Thank you. This is a collaboration of the World Bank in general on several years of harmonizing, collecting data. We are just building on top of that. Thank you.
Okay.
Your answer, okay. So any more questions? Okay, so
I just wanted to add that we are anticipating the release of the 2017 SAM soon. So you should look out for that.
All right, okay. Okay, that's good. So I think it's time for us to close up this session, wrap it up. Thank you all the 4 presenters for interesting papers and nice presentation. They were all illuminating. This labor market, and particularly modeling unemployment, has been a sore point for a long time, and we are all addressing this particular problem from different angles. So all the 4 papers have looked into this problem, search model, wage curve, introduction of hundreds of occupations into other hundreds of industries, and occupational mobility. And so now we're passing from a homogeneous labor, perfectly mobile labor market into this kind of complicated thing. So thank you all. Thank you all for attending and raising interesting questions. I now declare this closed.